Friendly neighborhood Mr. Hayes is back. Learning card number 9. We are going to talk about evaluating functions. And the great thing about evaluating functions is that in reality, you have already done most of this back in Unit 1, otherwise known as learning cards, I want to say 1 through 6. But it's just a different of making sure you get the notation right. And as I've said to my classes, this is one of those things that it's easy to say, oh, I got this. And then if you act like that, it's so easy to get things wrong, because once you start getting overconfident about this stuff and not practicing it, you will have your grade handed to you on a silver platter. So anyway, we got 2 of these, and I've got some memory tricks to hopefully help you remember this. But again, here's the big ideas here. If you're asked to find f of 3, and I've defined your, let me get a nice color here. We'll do green. I've defined your functions here. Now again, remember, function notation, this is pronounced f of x is equal to negative 3x plus 5. And g of x, that is not multiplication, that is not 5 times, or f times x. You never, ever, ever, ever will be multiplying that stuff out. So anyway, so if I'm asked to find f of 3, compare to f of x is equal to negative 3x plus 5. Now notice what's going on. The x is being replaced by the 3, so the 3 is the input, aka x equals 3. Aka is also known as, for those of you guys who aren't as old as I am. So what you're going to do here is that effectively I'm going to take this 3 and I'm going to plug it right in there for that x. And I'm going to replace it. The x is going to disappear. It's going to become a 3. So this f of 3 is going to become negative 3 times 3 plus 5. And then here's the beautiful part. Hey, that looks like what I already know how to do. And just simplify it. Negative 3 times 3, negative 9 plus 5. So I get negative 4. So f of 3 is equal to negative 4. I am having all of my students write it like this. Why? To help drive home that 4 is my output. If I plug in an input of 3, I get an output of 4. I have found when people just put numbers down, they easily get the 2 confused. So we've got the space. Let's do another one. If I asked for, find, let's say, g of 10. So the 10 is going to go in the place. So remember, x is equal to 10 here. So that means that this is going to equal 4 times 10 minus 7. Because again, if I look up here at the equation, g of x is equal to 4x minus 7. So then I'm going to get 40 minus 7. So therefore, g of 10 is going to equal 33. If I put an input of 10, I get 33 out. Now the memory trigger I wrote down here, and I go back and forth on these because I really want you guys to understand the concepts behind it. But, okay, it's inside the parentheses. If it's inside the parentheses, that means it's an input. If it's input, then that means you're going to put the number into the expression. Actually, let's even get rid of the word into the expression. Input goes inside. That's why it's part of the reason why it's called input. It goes into the machine. Now, let's say you asked us to do something else. And again, I'm sorry if I'm going too fast. Pause wherever you need to. Rewind it. It's all the standard stuff. It's YouTube. So if asked to find x when g of x is equal to 53, compare that to g of x is equal to 4x minus 7. That's an ugly equal sign. So the function is equal to 53. So 53 is the output. Or if you want to think of it as the answer. I don't like saying answer just because everybody thinks, that's the final thing. So anyway, so g of x is equal to 53. G of x is also equal to 4x minus 7. In geometry, you're going to use this substitution step quite a bit. Okay? So g of x is really 4x minus 7. It's also equal to 53. Some people would actually write it like this, which you can do. So g of x is 4x minus 7. It's also equal to 53, because that's what the problem says right here. Boop. So the two things are equal. And if the two things are equal, then you can set them equal to each other, and then guess what? Solve it. Just like you did a mere 3 weeks ago. Yes, you do. You are expected to know all of this long term. Then x is going to equal 15. So my input's 15, and it goes to 53. Ta-da! So it's really a notation thing. You know how to do all of the hard stuff. It's just a matter of getting used to where it is. And so again, if it's outside, so the memory trigger here, if the number that we're talking about up here in this highlighted area, let's get my magic pen so I don't have to erase it later. So right here, oops, okay, it's right there. It's on the outside. So if it's on the outside of what's going on, that means that it's output. And if it's output, you're going to set the number equal to the expression. Because the output's on the outside, input's on the inside. And that's it. Okay? The math itself is stuff you know how to do. So that's something to think about. I hope those things are helpful. And that should be it for Unit 2, at least here at good old Community High School. So if you have questions, please come in and ask. We'll put this up shortly, and hopefully you find it useful. We'll talk to you soon. Obviously, comment, like, subscribe, all the other stuff that if I was trying to be a YouTube star, I'd ask you to do. You're more than welcome to do it. Talk to you later.